Hey guys, I'm Rahul Baluri, and I'm the event captain for remote sensing. And I'm just gonna, briefly go over what the event is and how it's, you know, done pretty much. Yeah, just pretty much the basics of the event. So to start off, you know, um, in simple terms, to answer the question, what is remote sensing? Essentially, remote sensing is the collection of data about an object from a faraway distance. So what this means is the object might refer to a landscape or an ocean or something. Um, you know, Residential areas, pretty much anything from a distance. And by distance, what I mean is that these pictures are taken from a satellite in space. So yeah, um, satellites, um, by taking these pictures using certain instruments, they're able to produce images like the ones that you see below, and you can collect data from these images about these specific areas. So yeah, remote sensing primarily concerns with the Earth's lithosphere, biosphere, hydrosphere, and atmosphere. And what each of these mean is um, the lithosphere refers to pretty much the rocks, minerals, and the outer surface and interior um, you know region of Earth. Um, Biosphere referring to pretty much everything living, like vegetation, and the hydrosphere referring to pretty much all of the water on Earth, whether that be oceans, lakes, or rivers. So pretty much any body of water, and the atmosphere referring to, of course, all the gases and suspended particles surrounding the Earth. So yeah, that's pretty much all of the um, a really basic definition of what remote sensing is. Um, and yeah, apparently, as far as I know, for the test during for 2016 and 2017, the test will relate and focus more on climate change processes on Earth than it has before. Um, so yeah, basically, I'm sure you've seen lots of images like these before. The one on the left looks a lot more comprehensible. It makes a lot more sense visually than the one on the right. The one on the left is obviously just one taken that the human eye can process easily. Um, it's pretty much exactly what you're seeing um, from an aerial view, but things get more complicated with images on the right. They have a lot more extreme colorization, and it's a lot harder to tell exactly what's going on. But that's essentially what remote sensing is. Um, and yeah, I'm going to be going over that very briefly. Okay, so to go over some parameters of the event, to start out, this is a partner event, like most events throughout Science Olympiad are, um, and it's primarily a written test. It's not really a lab event like any other, like other ones. It's mostly just on paper. Um, it's approximately 50 minutes long, and the written test will consist of multiple choice questions. I believe a couple fill in the blank, maybe even true or false questions, um, and definitely some short answer questions. And yeah, and you can bring a couple tools. You can bring a metric ruler, a protractor, and a non-graphing calculator. Although lots of questions do just ask basic information, about like general knowledge and interpreting images. Some questions, for example, might ask, I guess, questions that are more centered around measurements. Like, for example, they might show you a picture of an island or a landscape, and given a scale, you're going to have to figure out the area of that particular island or something like that. So, um, yeah, you can use those tools, but it's pretty much limited to that, as well as a double-sided page of notes. There aren't really any requirements, as far as I know, at the moment, for these notes. you can make them as small as you want to or as big as you want to, as long as it's just one page of notes, both sides. But yeah, don't like pretty much like to have like an information dump on these notes because it's going to be a lot harder to find things and it won't really help you and your partner. More than if you just got to know the information better and put what you really needed to memorize, to write down on your notes. Okay, so now let's get into the heart of the event and what it actually is. So to start off, there are a lot of different satellites and instruments that actually take the images that I showed you before, like these two over here. And these are include, but are not obviously not limited to Terra. Well, the first bullet point consists of satellites. The second consists of instruments. So for satellites, they could include Terra, Aqua, and CloudSat. Terra referring is a satellite that provides data on the atmosphere, land, and water. So it's kind of like a general, I guess, satellite. Aqua focuses more on the water cycle, and CloudSat studies lots of different properties of clouds. So these are just three examples of a very long list of satellites. In addition to the fact that they use instruments to actually take their images and actually perform the process of remote sensing. So for example, we have CWIFS, MODIS, radar. So there are a lot of different satellites and instruments. And if you go over to NASA has a little website, which by the way is a great resource for remote sensing. I'll talk about resources soon. But yeah, there are a lot of different current missions going on right now, a lot of instruments that are being used and whatnot by all these satellites. In addition to the fact, here's just like pretty much another chart. It's kind of seems a little overwhelming at first. But yeah, there are a lot of acronyms, but I think if you kind of break it apart and see which satellites, how they function, which instruments they use, kind of piece by piece, is going to make a lot more sense. And also, one of the most core parts of all of remote sensing is the electromagnetic spectrum. And essentially what the electromagnetic spectrum is, I'm sure you've seen this image a lot in your science classes. Now I guess, here's the time where it applies a lot more than it probably has before. Maybe, in physics it applies a lot there, but for remote sensing, as you may know, there are a lot of different forms of energy and light, depending on their wavelengths. So, for example, there are gamma rays or X-rays, infrared, and of course the visible region that the human eye can actually detect is rather narrow in comparison to the large amount of actual energy that exists. That's essentially that's a key element to remote sensing because based on the images that we can see, images like these are only the ones that we can this is using light. All of these images are ones that the human eye can detect using colors that the human eye can detect, even if there are things in the atmosphere or the biosphere or whatnot that we might not be able to detect normally. So that's what images can really help us with. So it's also important to know that not every single piece of form of energy or type of energy can be used for remote sensing. So, for example, gamma rays, X-rays, and ultraviolet radiation cannot be used, I believe, for remote sensing because I think the first two are absorbed by the Earth's atmosphere and the other is blocked. Ultraviolet is blocked, so those cannot actually be used for remote sensing. But all of the other ones are definitely used, are picked up by satellites, and we interpret them using basic, visible light, using the narrow visible light that we can detect. So one of the most important, I guess, yeah, one of the most central topics to remote sensing is image interpretation, and I kind of touched on this a little earlier, but yeah, it's definitely something you really want to get familiarized with because it's a pretty difficult topic to understand. Um, but it'll really help you if you just get to know how it works. So yeah, this is kind of another situation like the one I showed you before. These two images, obviously depict the same kind of location, but they're different colored and there are different things that you're able to although it's the same basic area, you're able to it's like an image in it's differently colored and basically what's going on here is the one on the left is a true color image, and on the one on the right is a false color image. And basically, um, well, before we go there, let's quickly talk about. I forgot to touch on this. For the electromagnetic spectrum, there are different wavelengths for different energy, ranges, and these are used for different bands. And what bands are essentially they are bands are consist of all the information from a narrow wavelength range that are gathered and stored, and basically these all this information is put together to make an image. So building off of that, if you go back here, there are different wavelength ranges for both of these. So a true color image pretty much shows all of the the results that humans with the human eye can detect using visible light. But obviously, when an image like the one on the right is taken, it's using at least one non-visible wavelength. But that band is still represented in the primary colors red, green, and blue. So yeah, basically what this does is it actually picks up on things that the human eye cannot normally see, which is really important. Um, so yeah, that's part of remote sensing. This is another kind of um, sorry, an audio error there. Yes, sorry about that. So continuing, yeah, this is another kind of like example of how true color images and false color images can change between each other. So yeah, obviously there are three different pictures of the same kind of area, but all three are very different from each other. So the first one, this is the first one shows it's like natural color image, showing I believe it's of Florida, and it shows pretty much all of the normal aerial aspects that you'd see for this area for Florida. But the second image is the same kind of region, except it's taken with different bands, false color ones, non-visible light. So what this actually shows is things that we normally wouldn't be able to see. Like for example, the second image shows that the water is for example, we could see that the land is much more burnt, which could kind of give a little insight into how farmers rely on fire in this region. So, and the third one, in addition, the second image kind of shows how water flows. It kind of gives it um, a more in-depth view that we wouldn't normally be able to see with natural light. And the third image is again another kind of situation, except the plants and all the vegetation in this image is shown to be dark red because they reflect infrared a lot, and the plants that are growing more quickly, obviously, they reflect more infrared, so they're brighter red. So yeah, we can kind of based on this, we can kind of tell which images are more densely vegetated, and yeah, that's how pretty much how image interpretation really works out. So this is kind of a sample problem that we'd see. It's kind of a basic problem. Obviously it's probably one of the more simple problems that you might see for an image. But I guess it's a good start to kind of see how well you can interpret an image at the very basic level. So this problem asks, using the image given, identify the following basic components. So number one, if you want to find a racetrack, obviously it's going to be like the oval shape area in the bottom left. The river cuts down straight down the center. And roads are obviously shown to be these bright lights, in this black and white image that intersect many areas. Bridges, they go across the river, and they're identifiable based on their association with the river, the fact that it crosses it, and the residential areas are all the rectangular regions that are that make a conjunction with the roads, and the dam is the area at the top. So remote sensing, a part of it actually, this kind of gives a little insight into the different kind of, I guess, features that you want to be looking for, including tone, shape, size, pattern, texture, and a couple others. So yeah, it's obviously a very basic problem, but it gives a little insight into the features that you want to be looking for. And the second image, it kind of builds off of what I talked about with this third, scene of Florida, and it's basically asking, what does the red area of the image represent? And as we know, this particular area, this is a false color image, and we can conclude that the vegetation here is able to reflect more infrared and is thus more densely vegetated and thus more, essentially healthy. So yeah, essentially the answer is C, is healthy vegetation. So yeah, it's basically pretty much lots of the basic content that I wanted to go over with. Obviously, there's a lot more to go over. It's a pretty expansive topic. So if you go over to the event guidelines, there's a pretty good, it goes over, a lot of the topics that I didn't go over with. For example, lots of really specific things like active versus passive sensors. There's not a whole lot of physics involved, in terms of like equations and whatnot, but there are still a couple laws that you want to be knowing, as far as I know. Of course, the satellites that I mentioned, greenhouse gases and carbon cycle. As I do believe this event does focus a little more on climate change, and so if you want a more in-depth idea of what topics will be focused on, definitely look at the event guidelines in the resource folder. So yeah, moving on to some other resources. There are going to be a lot of starting from the bottom and going to the top. There are going to be a lot of practice tests we're going to be taking across over the course of the year to reinforce some material, get a lot more practice into things like just kind of getting used to what a test could be could actually be like, what kind of specific questions you might encounter. In addition to excuse me, YouTube videos that kind of give a more visual representation. There are a couple in the document called helpful links in the resource folder. And as I mentioned, the NASA website could be pretty helpful because it goes over lots of things in a pretty basic manner. In addition to physicalgeography.net, which also gives a pretty nice introduction. It doesn't go in depth as some other sources I'm going to be showing you, but it does give a pretty good idea of what exactly you're dealing with. And lastly, the most important, actually, a couple more links that I want to show you. We have a couple more specific links on the NASA website. This is a link called How to Interpret Common False Color Images. It's really helpful. It gives a nice tutorial and brief overview of what you want to be looking at. And I think arguably the most important resource that you want to be looking at is the Fundamentals of Remote Sensing textbook that's located in the resource folder. It's a pretty large one. It's approximately 258 pages, but it's not really like your typical textbook. It is definitely filled with a ton of information, but it's a lot more easy to understand than a lot more, a lot of other sources. I mean, it is a really extensive textbook, but it's able to put things in a really basic manner that I think anybody who's just getting introduced to the event could really um, understand. So yeah, it goes over the introduction, goes over a lot of basic topics like radiation and energy. It goes over image interpretation later and basic photography using satellites and a lot of different very important topics. So yeah, check out the table of contents. This is definitely a resource you're going to be wanting to look at. So yeah, that's pretty much all of the pretty much I guess remote sensing in a nutshell. As I mentioned, there are a lot of different, a lot more. There's a lot more to the event than what I just mentioned, but it's a good start, I guess. Yes. Also, sorry about the fact that this isn't a video cast; it isn't live, because there were a couple audio errors that I had recording the first video cast, but I decided to make a video. So yeah, I apologize for any issues, but you can still ask me any questions. Of course, feel free to approach me at any meetings, and of course, you can email me at the email that I have above here, upalurirahul@gmail.com. So yeah, thank you guys for listening. I really appreciate it, and I really hope that you got a better idea of what the event is, and whether you're interested in art or not. So yeah, thanks a lot. Bye, guys.